Oscillations and Waves. In this video, we learn how oscillations of particles lead to the formation of a wave. A mass resting upon frictionless surface is attached to one end of the spring while the other end being rigidly fixed to the wall. When the mass is pulled and released, it starts moving to and fro as the spring expands and compresses. When the spring is not expanded or compressed, there is no net force on the mass. The spring mass system is in the equilibrium configuration. When the mass moves towards right, the spring expands and exerts force on the mass. As a result, the mass slows down and stops momentarily at some point. At this point, the spring force is maximum. The mass is pulled back towards left. While passing through the equilibrium configuration, though the net force is zero, the mass continues its motion towards left due to inertia. The mass is slowed down again due to the force exerted by the compressing spring. The mass stops momentarily before being flung away. The expanded spring exerts force on the mass and pulls it towards left, and the mass is set into to and fro motion. The spring force maintains and limits the motion of the mass. The spring force accelerates the mass when moving towards the equilibrium configuration. When the mass is moving away from the equilibrium configuration, the spring force slows it down. This force, which prevents mass moving away from the equilibrium position, is called restoring force, as the force restores the mass in its equilibrium position when friction is present. Let's study the motion systematically. We represent mass by a particle. The particle is moving to and fro repeatedly. This motion is called oscillations. The term oscillation comes from the Latin word oscillatio, means to swing. The particle is moving along the straight line. The two end positions are called extreme positions, and the midpoint of the path, which is the equilibrium position, is called the mean position. The distance between mean position and the extreme position is called amplitude. The motion that repeats at constant intervals of time is called periodic motion. When the particle arrives back at any particular position with the same velocity and acceleration, one oscillation is said to be completed. Time taken for one oscillation is called period. The number of oscillations completed per unit time is called frequency. If n is the number of oscillations completed in time t, then the frequency is given by. Consider the row of particles in a continuous material medium. All particles are in equilibrium position. When a particle 1 is displaced from its equilibrium position, other particles also get dragged along due to attractive forces between the particles. When released, the particle 1 starts performing oscillations about equilibrium position. The next particles also follow and oscillate, giving rise to wave. The action of particles oscillating is called oscillatory disturbance in the medium. The oscillatory disturbance hit the particle 1 first, then to particle 2, then to particle 3, and so on, causing them start oscillations one after the other. The wave is defined as the propagation of an oscillatory disturbance. The wave consists of successively repeating pattern in space. The length of smallest repeating unit is called wavelength. Any particular portion of the wave appears to move in the direction of wave propagation with time. Its speed is called wave speed. This is the smallest repeating unit having a length called wavelength. When first particle completes one oscillation, any particular portion of the wave starting from particle A travels through the distance equal to the wavelength. That is, in one time period t, the wave advances through the distance of wavelength lambda. The wave speed is thus given by v equal to lambda divided by time period. Please subscribe, like and share. Thank you.